Okay, when I cut away from that last video, I forgot I have a couple more to do. Again, just to add some trig identities, some quadratics. So just some more practice so you guys can see this, all the algebra, all the trig, and this trick of using revolutions and whatnot to help us solve things. So in this first one, what we have going on is the fact that I can see I have a cosine squared of 4 theta, and I have a cosine of 4 theta there. So that tells me we've got a quadratic. So how about we kick everything over? So we have 2 cosine squared 4 theta, right? If we move this over, that's a plus cosine 4 theta minus 1, and that equals to 0. So again, we're hoping this factors, and I believe it does. This is 2 cosine 4 theta. I think we have cosine 4 theta, and I believe this would have to be a plus 1 and a minus 1. I think that does the trick. Negative, positive. Yep. All right, so we basically have, using our zero factor property, each one of those can potentially be 0. And so moving things over here, we get cosine of 4 theta equals a half. And over here we get cosine of 4 theta equals negative 1. And so again, because we are quadrupling the angle, we're actually going to have to go 4 revolutions out. And just for simplicity, let's go ahead and keep things in degree mode. So from 0 to 360. So for here, this ratio of a half and the fact that we're positive tells me that we're in quadrant number 1 and quadrant number 4 with a reference angle of 60 degrees. So that basically tells us that 4 theta is 60 degrees and 300 degrees, and that's all in the first revolution. So if we go the second revolution, I just keep adding 360. So 360 to 60 would give us 420. And then 360 to 300 would give us 660. So there's your second revolution. To do the third revolution, I just keep adding 360. So 360 here would give us 780, and 360 here we get 0, 2, carry the 1, I think 10, 20. And then last but not least, since we're going 4 revolutions out, I got to go 1 more revolution. So adding 360 to this, we get 0, 6 and 8 is 14, carry the 1, 10, I get 1140. And then last but not least, 360 to this gives us 380. So there's all those guys there. And of course, to figure this out, we now take everything and we divide everybody through by 4 to get what we need. So it looks like the first angle is 15 degrees. The second angle, when I do that, I think we get, I believe, 75 degrees. Right, and the next one we end up with 105 degrees, and the next one, I guess, 126, that's 6, 165, and then 780, 7 into as 1, we end up with 38, which is 8, and that's 40. I'm gonna turn to my calculator for that one. All right, so 780 divided by 4 gives us 195. I thought I was a little off there. So 195, 1020, 10 divided by 4, it goes in twice. So that gives us 222 divided by 4 goes in 5 times. So the remainder 255, right? And then 1140, that goes in twice. 34, that goes in 8 with remainder of 2, 285, 13 divided by 4, that's 3 times, 18, that's 4 times remainder 2, 345. So there's all our angles. You do see that they all fall within 0 to 360 just for that guy, right? Because we now have this dude, right? So the cosine of 4 theta equals negative 1. Well, in the first revolution, right, the cosine is negative at 180 degrees. So that's the first rev. So second rev, adding 360 to that, I'm tired of doing the mental math. So 180 plus 360, That gives us 540. Add 360 to that again. That gives us 900. And then add 360 to that again. Oops. That gives us 1260. So there's all the revolutions. Now, of course, we have to divide everything through by 4. And that gives us all the solutions there. So our theta ends up being 180 divided by 4. What's that going to be? 45. Okay. Again, let's just go to our calculator. Sorry. So 180 divided by 4. Yeah, there's 45. 540 divided by 4 gives us 135. It looks like we have, I think the next one will be 225. And I'm going to bet my bottom dollar that this one is 315. So there's our solution. So we actually have 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 total solutions for this one brought up these 4, and this one brought up those 8. Again, using the trick of going out and coming back in. All right. So there you have it. So we saw a quadratic. We saw a changing period of 4, which meant I had to go out 4 revolutions. We had some nice ratios, so I could use my special angles. I didn't need my calculator. All right, so the next one. We got cosine of a double angle, and then we have 4 sine theta, cosine theta. So again, looking at this one, let's leave this one by itself for the moment. Although I guess, yeah, let's go ahead. And here what I end up having is, this is 2 times 2 sine theta cosine theta. There might be an easier way to solve this, but I'm trying to help you guys see identities as fast as we can. So 2 sine theta cosine theta, this is cosine 2 theta equals 2 sine of 2 theta. And at this stage, if I divide everybody out by 2 sine theta, what I end up getting is this goes away, leaving us with 2, but cosine over sine leaves us with cotangent of 2 theta. All right, which means we're talking about the tangent of 2 theta equals 1/2. All right, so there's all my work there. And at this stage of the game, I can see that I'm going to need my calculator, right? Because half is not a nice ratio for tangent. And we're also going to have to we're going to have to go out 2 revolutions to get all my solutions. So let's go ahead and first, let me call this beta for the moment, right? So beta is the arctangent of 1/2. All right, so invoking my arctangent of 1 divided by 2, right? We get that beta is 26.5651. Okay, so that's that angle right there. And so what we can basically do, right, tangent is positive, we know in quadrant 1 and in quadrant 3. So that means that I have a 26.5651 degree reference angle here, which means I got a 26.5651 reference angle in quad 3. So my other angle that I have, the other beta that we need, would be 180 plus that. Okay, so let me just add, oops, don't want to do it there. All right, let me move out of there and add 180 to that. And so we're getting the other beta value. Let me come back up here. It looks like it's, because I lost you guys, sorry. The other beta value is 206.5651. All right, so what we have then in the first revolution, let me come back to 2 theta. Our 2 theta is equal to 26.5651 and 206.5651. This is in the first rev, but I need to go the second rev, which basically means I add 360 to this, right? So adding 360 to everything, if I add 360 to this guy, I get 386.5651. And if I add 360 to this guy, I get 566.5651. So there we have it. So to get my theta, I now need to divide everybody by 2. And let's just go ahead and do a few of these. Well, there's only 4 of them, so I'll do them all. So we get my calculator 26.5651 divided by 2. That gives me 13.28. Looks like 23 if I round off. So there's one of my angles. The other one is 206.5651. So that looks like 103.2823. And doing the next one, I think I'm off there, sorry about that. Doing the next one, we have 386.5651. So that's giving me 193.2853. And then the last one, we got 566.5651, and that looks like it's 283.2853. All right, so 23, excuse me, 23. All right, so there they all, and you notice they do fall within the 0 to 360 range. Right, so kind of a nice one there. We used a couple double angles. We're stretching out the period, so I'm having to go out a couple revolutions, using my technology, using my idea of reference angles. So a lot of things going on in that one to help us out. All right, I am going to cut one more video because I kind of tanked on that secant tangent one. I'm going to show you another way to do that one, even though I miswrote it. But it's good for you guys to see how to solve that, because it brings in something that we haven't seen before. So I'll do that in a moment.